We're going to look at how we can generate the addition cosine compound angle formula from the subtraction cosine compound angle formula. So I'm going to start by setting up my expressions here. So I have a left side and a right side. So I'm going to start by writing our subtraction compound angle formula. Cos B plus sine A sine B. So then I'm going to go to a new line, and I'm going to start by writing cos of A plus B, and that can be rewritten as the cosine of A minus negative B, which then we can manipulate so that it's going to look like the cos A minus B. So when I expand that, I'm going to have cosine A cosine of negative B plus sine A sine of negative B. So I'm actually going to insert that math now, and then we're going to review something that we need in order to be able to continue with this. So I'm going to insert that. I'm going to move it so that you can see it. And then we're going to think about some relationships that we know. So we know, if I click out here, I don't want that there. So we know that the cosine of negative B is equal to the cosine of B. Because remember, if I have B is here, negative B is here, our x value is the same, so we get the same equation. So if I were to do cos of 30 degrees, I get root 3 over 2. If we do the cosine of negative 30 degrees, we also get root 3 over 2. Sine is a little bit different. So sine of negative B is equal to negative sine B. So if I'm doing sine of negative B, that's down here. So that, if I was also looking at 30, so sine of 30 degrees, of negative 30 degrees, I should say, is negative 1 over 2. And if I were to look at 30 degrees, oops, something happened there. If I were to look at positive 30 degrees, I would have negative sine of 30 degrees equals negative 1/2. So because of that relationship, when I go back to my expression that I have here, and I go to Edit Math, and I have my expression right here, and I add in a new line. Whoops, my equal sign needs to be over here, so equals. Cos of negative B is the exact same thing as cos B. So we have cosine A, cosine B. And then I know that I can have plus sine A bracket minus sine B. So I'm substituting in an equivalent expression. So I need one more line here to clean this up. So that gives us cos A, cos B minus sine A, sine B. So hopefully that helps you better understand how you can go from one expression to the other. It all comes down to recognizing those relationships between sine and cosine and how ultimately they're the exact same periodic function, just shift it slightly.